And up next, we have the great Lucas Martin Calderon from Pentestify, sorry. And he will be talking about the latest advancements of AI in blockchain security and how deep reinforcement learning compares to static, dynamic, and formal verification techniques for DeFi security. Everyone give a big round of applause.
Amazing. So hello, everybody. I'm super happy to be here, especially because I've been thinking quite a lot about what to speak about today, whether to speak quite technically about what AI is, comparing our tools to other world-leading tools like static analyzers, dynamic analyzers, formal verification tools. But at the end of the day, I actually decided to truly maximize the impact, go back to the basics. So how really AI works, to be able to understand where the future is heading to, and to be able to, when you guys, which I imagine are quite entrepreneurial, have an idea, something to do next, you're able to really get the basics well, get the basics right, and hence develop a product that really makes a difference. As Elon Musk says, one of the problems with entrepreneurs, with smart engineers, smart people, is that we focus on the wrong problems. So we try to optimize and maximize problems of things that shouldn't even exist. So who here in this room is afraid of AI, as in replacing your job or actually taking a bit of your job? Is there any takers for that? Of you guys. Okay. So first of all, if by the end of this talk you feel a little bit worse and so on, that means that I've done a good job, a little bit. So again, we are going to talk about how AI works, why you should fear AI, the ways to think about it, and the exact same thing for the blockchain. So already, what is a neural network? You already have some inputs. In the middle of the inputs and the outputs, that's where the layers come in, right? That's where you have some weights. The weights could mean how strong the system is, how strong the relations between these variables is. Then those B's represent the bias. So in a loss function in an AI model, that means to minimize the error, the loss function, the cost function. And then you have an activation function, which could be softmax, ReLU, sigmoid, to simplify the output. And finally, you have the outputs, which generally could be it's a car, it's a carpet, it's a mug, or that would be classification, or it could be regression regarding numbers and so on. So again, we've talked a lot about, and we've heard about ChatGPT, LLMs, transformers, what they do, how they work. And I would like to give a very basic explanation, but yet enough for you guys to understand why ChatGPT or different LLMs wouldn't be apt for certain things, certain vulnerabilities, and so on. So I don't know if you can read it well, but ChatGPT is made of, or transformer networks is made of encoders and decoders, right? Encoders get your input when you put text into ChatGPT, and decoders actually get that context and decode and output the end result, right? And it's quite easy, and well, it's quite important to understand how self-attention works. That actually comes from a paper from Google called Attention is All You Need from 2016. Actually, it's quite old, but it's the basics for all we've got right now. So if you want to use these tools to find vulnerabilities in smart contracts, that's a bit more tailored to smart contract security auditors, you already start wrong if you use a pre-trained model. Why? Because the attention mechanism of LLMs, of ChatGPT, is already tailored to optimize and maximize the probability of the next word, right? So according to your questions, according to the tokens and the whole embedding, what is the probability of the next word popping up, right? This is important to know because if you think about mathematics, if the smart contract does some mathematical reasoning, when you ask it 5 plus 5 and it outputs 10, it doesn't know what 10 means, or it doesn't know what addition means, or what 5 represents, signifies. It simply means that after all the terabytes of training data, academic papers, and so on, most of the times there is a 10 at the end of the thing. So do you want that to be piloting, to be driving the security of your Web3 company? I definitely hope not. So when thinking about all these things, on the right, as you can see, that's simply how AI sees the input text that you put. When we call artificial intelligence, is it really intelligent? How intelligent is it? The stability of the CEO Stability AI said that by the end of 2024, I might be wrong about this. Well, already it's not me who says that, but I do agree and align with him, as in we will be able to have ChatGPT on our phones, downloadable, and the size would be 5 gigabytes more or less. Doesn't that mean a lot already? You're able to train on terabytes of data. You're able to put a big portion of the internet, of the best books, of the smartest academic papers, and then you're able to download all that information into 5 gigabytes. Are we talking about a sort of compression algorithm? Are we talking about something else? That something else is what we interpret as intelligence, but however, we plan to transpose our intelligence to what this AI, how AI works, right? Which is something completely different. This is why, when really thinking about security, and even though certain models might output certain vulnerabilities of smart contracts, you truly need to understand how it works first, what kind of intelligence or compression algorithm it has, or pattern recognition, to know the limits of its creativity, of how it works, and so on. This image is simply what the AI sees in the first step. So if you see these are the word embeddings. All the features, all the rows, so each row is a token, and each column is a feature of the token, a dimension. A dimension could represent different things that we cannot even imagine in that case. It might be word similarity, semantic similarity, and it's quite important for the self-attention algorithm. This is taken actually from Jay Alsom, one of the best illustrated engineers that are able to express with graphics how AI works. And in this case, for example, that it says, the animal didn't cross the street because it was too tired. When you refer back to the whole graph, to the whole way of seeing things by the AI, what does it represent? Does it go back to the animal, or does it mean the street, right? This is where attention comes in and where it's tailored to certain parameters. In this case, ChatGPT is tailored to make sense for the questions that the user asks them, but it's definitely not tailored, engineered, made to find vulnerabilities in smart contracts. Now, however, we would like to talk about really the opposite of the monopoly of AI, and why AI companies should fear AI, and why it is really down to the community, and this is the message that I want to put across. It should be up to us, up to the community, to really drive and set the pace for the future of the developments in Web3, including AI and blockchain, and not to these big corporations. So GPT-4 was the first one, the most known one, well, commercially available, even though Google started way before. Then we've got Cohere, Stability AI, Claude by Anthropic. Some engineers from that already were working there. And then, in this case, it seems that Mark Zuckerberg is actually one of the good guys, one of the biggest research companies putting their research out there for free. This is how fast, by the way, AI has been working. So since the first moment ChatGPT was released, on February 24th, Llama was released, but it was open source, and yet the weights of the model, that means the intelligence after the training model, they were private. Somehow they got released from 4chan, and since then there has been a super fast acceleration of people building on top of these tools. To give you an example, on March 13, it was already running on consumer hardware. On March 19th, Vicuna, another model, already surpassed Google's Bard. So something that was around $200 million to train in the AI database, and computing zones, it already takes $300, $300 to fine-tune the model. Fine-tuning simply means making it better after it's already pre-trained or tailored to your needs. GPT-4 all launches, and it already creates an entire ecosystem. The biggest LLMs, open source libraries like LangChain, like Weaviate, the vector database, already try to pop up and catch up with the speed. On March 30th, Bloomberg GPT launches, and shortly after FinGPT, so Finance GPT, the open source version of that launches as well. So as you can see, since the weights of Llama were put out in the wild by, well, definitely not by Meta, but by someone else, I guess an insider, in less than 6 weeks, we were already able to get the same performance or very similar accuracy, F1 scores, precision, that models that took years of development and hundreds of millions of dollars to train. So this is again the moat. There was as well a leaked article by Google saying OpenAI has no moat, and neither do we. By moat, they simply mean competitive edge, competitive advantage, and it was already possible given certain technologies, certain advancements in the field of AI that allowed all of that to happen. However, it is important to note that you're able as well to fine-tune the model simply by prompt. So you don't need to do that technically. Prompt and giving context already kind of helps that out. But speaking of the technologies that actually helped the open source community carry all these advancements forwards and actually achieve the same precision or similar precision than Google or OpenAI were two main technologies, quantization and LoRa. LoRa is not to be confused in the electronics field, but it is a lower rank adaptation that allows actually to reduce the number of trainable parameters by 10,000 times, which actually reduces and helps free up the bottleneck of AI training, which is generally the GPUs. And then quantization, it is faster inference, it saves money, and you're able to simply, when the training happens and on inference, you're able to reduce the vector space, which is used to train the model. So now the problems with generative AI, and this is really where the research that I've been doing at Pentestify, and as well in collaboration with University College London, we've really wanted to approach it in the most natural way. And by natural, I mean one of the human's best inventions, or rather than inventions, executions and engineering achievements were actually when we observed nature. So what best to represent how a human finds vulnerabilities and thinks of vulnerabilities than actually studying the brain and seeing the brain how it interacts when presented with a smart contract. So we took a bunch of auditors, 50 smart contract auditors, and we put them on an MRI machine to know actually the areas of the brain that activated when doing these things. A lot of noise happened, but we were, thank God, helped by medical professionals that know exactly how to interpret and read that data. And actually, it aligned very well with the philosophy at the beginning that we carried at Pentestify, and it was, what kind of AI should we develop to really find vulnerabilities without having the same weaknesses as OpenAI or ChatGPT. Again, we don't want to optimize a problem of an issue that shouldn't exist in the first place, right? So we realized that the answer was actually the true intelligence for this very specific task was mixing different types of intelligence, and we realized that when spatial and vision activated in the brain, there's already an AI model tailored for that, and it's called graph neural networks that are able to think sequentially through time, through functions. Again, a smart contract auditor, when you're creating or auditing the code, you might think of the control flow or data flow diagram, right? But you might be thinking directly with all the different function calls across time or in different order that it was already meant to. So graph neural networks are indeed able to achieve that task and have different information in parallel at the same time. The language area in the brain already was quite active, and for that we use part of LLMs like ChatGPT, but only up to the embeddings point. And the embeddings, again, it is the representation of the tokens of the words that you put in. And we wanted to make sure that the attention algorithm, the attention mechanism, was tailored to find vulnerabilities instead of to understand the semantic context of it, because at the end of the day, we don't want the AI to understand the smart contract per se, the semantics of it. We want to understand the different instruction sets and its interactions with the EVM. And there were a bunch as well of algorithms like short-term long memory algorithms and so on for prediction, mathematical reasoning that we already know that ChatGPT might not be the best at. In fact, even though it improves, it is definitely from the base, from scratch, the wrong algorithm to think and the wrong AI model to think for these things. So, well, I hopefully can skip that one. The blockchain, how it evolves, the good ways, the bad ways. Well, the fact that that is on right doesn't mean that I don't agree with those two, but it's definitely something that we should take into consideration. The fact that both things exist at the same time and the need for both things to exist at the same time. For the first time in history, our money in banks will be programmable. That means that if you receive money from your job or from even your own venture, you might need to spend it in a timely manner, because otherwise you could get burned, or you won't be able to route it through certain channels because it would be forbidden. Again, control has never been so active. So again, what is the best way to marry blockchain and AI in the context of security, and why is it so interesting to mix them in? Is it simply because in Web 2 AI was so prevalent? Well, in this case, it really helps the infrastructure of blockchain. The availability of the data is there for the first time, is public. We've given up the control for our data to be public, for certain transactions to be public, for at least the pleasure of not being stored in a centralized server that someone else controls and not you. The sector is about to change as well, with different encryption schemes. FHE, ZK are definitely there to change the game. And if you want to simulate different aspects, different attacks on the blockchain, it's never been so easier with an infrastructure that you can fork, that you can literally copy and simulate it. Why is the security aspect so important? Even though this is not a double sale that I need to make here, I'm sure. In 2023 alone, there was 3 billion over of attacks, of stolen dollars. 70% came from smart contracts, and 92% of these smart contracts were already audited by top firms. This is nothing to say of these top firms, but rather the fact that it evolves, that new vulnerabilities are found, and most tools are actually, when referring to static analyzers and dynamic analyzers, they have predefined instructions, predefined vulnerabilities. So again, the very basics of AI, of deep learning, is being able to train to inference on unseen data and being able to infer new vulnerabilities that you haven't even learned the patterns before, or hasn't been entered by an expert. So that's what we do at Pentestify through 5 different AI models. You give us simply the address of the smart contract. We get all the vulnerability. We get all the dependencies, all the graph from the different smart contracts. And across time, we continuously monitor it. We extract the vulnerable patterns. We store them in a database. Many of them are not vulnerable. But given that it is in a multidimensional space that not even humans can understand, as you saw in the graph, embeddings are using way more dimensions than what we can possibly imagine. That remains on the database until a smart contract with a similar vulnerability is found, and then we alert the team immediately. And we are able to find variations of vulnerabilities like reentrancy that a static analyzer wouldn't unless it receives an update. So yeah, thank you very much. More than happy to answer any questions now or after. I was only able to touch upon on an overview, not in detail, many topics, but happy to answer any questions.
Chris, and yes, now it's time for questions. So if anyone has questions, please raise your hands. We'll start with you first.
Can you explain the triangle from about 4 slides before?
No, so it's simply what are the limiting factors of AI once you're scaling it for training and inference. There are 3 triangles, which is data availability. There is also the compute and storage. Where do you store it? How do you ensure the integrity of it? And there is the what kind of model do you use? The model relates very much to the state of the blockchain. If you change the model, you might actually be changing the weights of it, and you might make it dumber, right? This is the exact same thing as if the blockchain changes the state by the consensus, but it wasn't the right thing to do via an attack. So when you put it in a big enough scale, you end up seeing that they also share many of the problems, whether it's the state of the model and the continuous change, or how do you ensure the data integrity of all the data. Yeah.
Yes, I've seen your hand. Right, so yeah, you go next.
Yeah, thank you for the talk. I have 2 questions. First, the AI modules that you use, what is the input and the output? Do they output like human-readable descriptions of vulnerabilities or pieces of code or malicious transactions, or like how does it look like? And second, I want to know if you are able to identify any like new types of vulnerabilities that auditors haven't even thought of before. Thank you.
Yeah, no, good question. So the inputs, we in fact are experimented with 2. The product only uses 1. We act directly on bytecode, so that is where we get all the instructions. There is a way, by the way, to as well clean out the bytecode if it's obfuscated or some things, but that has nothing to do with the AI. It's a bit more static, that process. So from the bytecode, we are able to obtain the graph, the general graph of the function calls, of the edges with the data, the control set, how strong they're interlinked, whether a single variable, a storage variable, shares different function calls, and if so, which function calls, are they the same link? That means, do you have an access control problem right there, or are you not supposed to change that variable? Should that be an invariant and it's changing? So you can definitely obtain all that information from graphs. We've been able to find or to have certain positives in the results that we didn't quite understand how to attack them, how to exploit them, or if they were even a vulnerability. But after experimenting and I don't even know there is a name for certain attacks that we discovered, it was indeed vulnerable. So it doesn't act on classification, on that expert pattern relates to reentrancy, let's say, or relates to access control, or relates to something else. Plus access control, you first might need to know the business first to know that. So after tinkering, we were able to see that it was indeed vulnerable, even though there is not a classification of that. And that is, again, because of the whole multidimensionality of how the AI sees the smart contract. And that is one of the main advantages, that it thinks of vulnerabilities even before we can think of one, or put a name to it, rather.
Thank you. And I believe we have time for one more.
Generative adversarial neural nets, and trying to get those things to play against each other like they would play AlphaGo or they would play StarCraft. Has that been explored? Has that been ruled out? Is that something on the roadmap?
Yeah, super good question, and that's what we're playing with as well. We haven't obtained many conclusive results, so I'm not able to speak objectively of how much better it is. But if you play with that and deep reinforcement learning, you're able to create agents in parallel, right, that act on different environments. And what if you could detect a vulnerable graph that we were able to do already, but create variations of that graph, right, that might relate to different ways of attack, right, and playing one against the other. Again, we can already fork the blockchain, we can get that reward, whether it is positive, that means that it was exploited. So yeah, playing different AIs against each other to know which one wins, which one really got that positive reward is something that, again, I'm convinced that it's another venue of finding vulnerabilities, and new ones even, because you're generating new graphs, new interpretations of data, and for sure that's a very smart way to think about it as well. Yeah.
And so the definition of vulnerability, could it be abstracted to more of a game theoretic definition? Instead of it being a hack, it's a, for example, poor game theory dynamic. The game theory, like the table doesn't match what the white paper says. Could something like that be interpreted from such an AI?
Yes, that's a bit more higher level. You need to understand the business, the logic, the semantics of the smart contract, or the business behind. We are purely focusing on bytecode, but if you're able to input, again, automatically instructions of what shouldn't change, or given that the business is that way, that definitely shouldn't be like that, or that variable should never contain that data. That is something, again, the possibilities are endless, and you would need, an LLM would be a good option for that too, on the other side of the smart contract, yeah.
Unfortunately, we have no more time for questions. Thank you very much, Lucas.
Thank you.
Everyone give a big round of applause again.